Hello everyone, this is Addy here, and this is the second part of my IoT video series. This is IoT architecture. So I'll be explaining about how the IoT architecture is in short, and we'll be going in detail for each module of it in the coming videos. Right. So IoT architecture. Now this architecture is a block diagram for different hardwares and the software blocks which are required for a complete IoT end-to-end application. It's not, I won't say it's highly completed, but yes, the major modules have been covered into this architecture diagram, but it's not completed as such. I'll be explaining you each and every part of it and how every hardware and software fits into it. So just to give a small map of how this entire entire architecture block diagram is and how the conventions are. Blue means the hardware blocks, that is the hardware which is required. Yellow means the actually the terminologies which are being used, or actually the yellow means the software blocks, sorry, and the green means the terminologies which are being used. So uh, blue for the hardware, yellow for the software, and green for the terminologies. So by this the IoT concept as well, okay, we have increased the scope of hardware engineers and software developers. Previously hardware engineers used to work for big corporates developing their hardwares or maybe researching on the hardware, and there were very few opportunities over there. Because of this IoT, there are a lot of opportunities which have been increased. They can create their own hardware, they can sell it as a product, and they can monetize it. So the scope for hardware engineers have increased a lot in IoT. It's there are unlimited possibilities of innovation using IoT applications, and you can think of various applications, various sensors you can create. You can create gateways, you can create a lot of things from scratch itself and taking small units together. So for scope of hardware engineers have increased a lot. Not just that, the scope for software developers has also increased in this. Why? Because you can see over here, as I mentioned, yellow means the software parts, right? Software blocks, and you can see yellow is dominating all the places. Now the software engineers earlier used to do UI applications or server related applications, but now they can work on multiple uh, software requirements on multiple places. As you can see over there in sensors, you can have your sensor interfaces, network interfaces, microcontroller, you can write your operating system, APIs, sensor libraries, network drivers. On communication protocols also, you can write your own protocol if you want to, or you can reuse those protocols which are already there in market. You can leverage them. Cloud technologies, there is already working, people are working in cloud technologies, web technologies, mobile and native applications, as well as there's a lot of scope in analytics also. So software engineers as whole have a lot of scope in this IoT, as well as hardware engineers. So both of them work in synergy, and that's how this complete IoT uh, application can be developed. So coming to it, that what are the basic components in this architecture which are being required. So coming on to the hardware side, yes, as I mentioned in the previous video, sensors are the most important ones. So they are the, you can say, the starting point of any IoT application. So these sensors, which are the hardware which is required, so they start off yeah, as a device which can send data to different to another hardware or maybe to the internet directly. So the sensors come in different you can say configurations. Now some have onboard chip into it, some don't have, some are just analog sensors, some are digital sensors. So they depend on what type of sensors you are using. Next comes is a microcontroller. Now this is something which as I mentioned, right, can have, you cannot have. With the sensor already having a chip into it and which can directly send data to the internet, you may not require a microcontroller. But in many cases you might require, because there could be multiple sensors in your particular application and you need to integrate that, right? You don't need to send data from each sensor to internet, and that will block the traffic. It will increase the traffic unnecessarily. You need some controller or maybe a gateway which can take that data, understand, analyze that data, and then send it forward. So for that reason microcontroller comes into picture. So microcontroller is another chip, you can say, which is onboarded with memory and other hardware specifications, like you can say the communication specifications also is there, so that you can add up some communication hardware to it directly. It has as I mentioned, it has an onboard memory, so that will help you to upload your code, execute that code. It has a chip in a processor which does the processing for this particular code. So it has a lot of components which are very useful for interfacing to directly to internet, or maybe do some logical calculations, thereby itself filtering out data as such. So microcontroller play as a kind of a brain to your sensors, and that's why it is required. So let's understand the software components required in microcontroller. So main software component which are required is the operating system. It's not compulsory that every microcontroller needs an operating system. Some microcontrollers don't need it. So but few high-end microcontrollers do need an operating system to work upon. They are like smaller computers, you can say, and they need require operating system to create interfaces for different hardwares which are for which are inbuilt in them. And some basic microcontrollers, they don't require it. So what are the other software components required? Sensor libraries. Now some libraries are required which can have an interfacing with your sensor hardware. So it depends upon the sensor which library is required for them. Network drivers, there might be some network interfaces also, as network libraries I would say, which are required to connect with the network hardwares. API is nothing but your software which you have created for for certain purpose. Like I mentioned, right? It can filter out data, or you can you can assign specific pins or specific input and hardware, input and output pins. For pins is the GPIOs I'm talking about. So specific input and output for specific sensors that way. So that API, that logic which you have put in to, so that you can understand what is the sensor's data, and you can also manipulate that data. You can put logic to manipulate that data. Like for temperature sensors and all, they send in values between 0 to 1024. Now that needs to be some logic needs to be put over onto it, so that you get the exact value of that particular uh, from that particular hardware. So that all logic you need to put in the microcontroller. Now as I mentioned, is not 100% required. The reason, because some sensors come with inbuilt chip in it. But as I also mentioned, the use case wherein there were multiple sensors talking to a single device, and that single device is sending data to the internet, instead of all these sensors sending data to internet directly. So for that reasons, this microcontroller is required. It's, as I mentioned, it's a brain. So as well as the software is also required in this microcontroller. And about the operating system which I was talking about, microcontrollers have different type of operating system which needs to be placed. Unlike our uh, Windows XP or Windows 7 or Windows 10, this Windows 10 IoT operating system is a different one, which is a thinner or lighter version of Windows 10. So this heavy, even Linux based operating systems like Red Hat and all, so these are little heavier footprints, and they could be little tough on your microcontroller which is having lesser configuration. So there are thinner versions of this operating systems also, which can be used on the microcontroller, which can be installed on the microcontroller, and they work efficiently as required. So all depends upon the use cases. So according to your use case, you need to choose your microcontroller as well as the operating system or the software which you need to place onto it.